Hello, and welcome to Tech to Tech presented by KYZEN, where we will explore common cleaning questions and answers. Let's get started. I would like to introduce KYZEN's own Jason Schwartz.
Thank you, William, and thank you everyone for joining us today. We're going to talk about how regulations push innovation, in particular, how we've developed a new product, CYBERSOLV 141K. 141K is an aerosol flux remover. It is the successor to our CYBERSOLV 141X. So let's start by talking about the current aerosol flux cleaner options on the market, including the 141X. So 141X, as well as other popular aerosol cleaners like the 3M Novec Flux Remover or Flux Off, a lot of them, they're all trans blends. And so what does that mean? Well, the main cleaning agent is trans dichloroethylene or TDCE. Trans is a great cleaning solvent. It's used in a wide variety of applications, including electronics cleaning and rework, but it's flammable. And so in order to get it working safely in your plant, you've got to blend it with some flame retardants. And I've picked out a little spot of the SDS for our previous product just to show you what those flame retardants might be. So you've got the trans, and then you have these three rather long names, and I've given you some chemistry pictograms here to go along with it. We don't need to get too far into the weeds, but just to point out that as you can see, fluorine is one of the main components in all of these solvents. And that's because it makes a great flame retardant. It's a very inert chemical when it's bonded into these hydrocarbons. However, you may have heard the term PFAS, and that is the new target regulation from the EPA. And what is a PFAS? Well, it's a poly and perfluoroalkyl substance. So we were just talking about how fluorines really help with the flame retardants in these trans blends and really what makes them safe to use on your factory floor. Well, those are one of the things that are going away. So why is a PFAS bad? Well, the main thing is it's a forever chemical. So although they have a lot of really good purposes and industry uses, they can very much be built up in the environment, whether that's people's, animals, drinking streams, etc., and kind of linger around, whether that's in our bodies or somewhere else. So the EPA is targeting them to be removed. They've really gone after 3M, which is one of the major chemical manufacturers in the U.S., and not only the U.S., but the world. And 3M has preemptively agreed to exit all PFAS manufacturing by the end of 2025. And 3M supplies almost all of these flame retardants in the US, not only for our flux cleaners, but their own. So if we look ahead on their schedule here, they said 2025, but they're preemptively discontinuing a lot more products earlier than that, including the 3M Novec Flux Remover, right? And so that product, you can't even place a new order for it. You'd have to buy it through a distributor or another third-party source. And as you can imagine, pricing's getting jacked up for that very quickly. So what has KYZEN done with these new regulations to help avoid discontinuing our products? Well, we've moved to what's called HFO technology. So HFOs are hydrofluoroolefins. Olefins are also known as alkenes, and the main part is that they create or they have carbon-carbon double bonds. They're very stable in solution or in the blends, but they're a little bit more reactive than the carbon-carbon single bonds that you see in the previous generation solvents. And this is nothing new. As you can see, we started with CFCs, HCFCs, HFCs, HFEs. This has kind of been a natural progression as we find out the solvents that we're using have some undesirable properties. We adapt and we adjust. So the HFO is the next in that line of technology. And so why do we want to use it in a trans blend? Well, because those flame retardants, which have all of the carbon-carbon single bonds and a lot of fluorines, are being regulated out of use, we've gone to this new product. And not only is it non-flammable, but it's VOC exempt. It's not a HAP. It has a very low global warming potential. And most importantly, it's got an atmospheric life of only 27 days. And that's due to that double bond here. So as you can see, we still have a couple of fluorines, but this double bond allows it to break down in the atmosphere and makes it exempt from being a PFAS. It's going to break down. It's not going to stay around forever, and it's not being targeted by the EPA. It's also got a very high personal exposure limit, even higher than the trans dichloroethylene. So when we blend it in, it has no effect on the safety of the product regarding operators. So as with all new products, there's some concern about, is it really going to work in our product and has it been tested out? Well, we have a very strong confidence in HFO technology because it has been vetted. It's been vetted by some of the highest sources out there, NASA and the US Navy. So NASA's actually certified HFOs to be used in liquid oxygen components or LOX. And as you can imagine, something cannot be flammable if it's going into a liquid oxygen environment. Things can go very bad very quickly when you have that much oxygen around in such thing as a solid rocket booster. So the Marshall Space Flight Center, the Stennis Space Center, and White Sands out in New Mexico have all done extensive flammability studies with these products and certified that HFOs are non-flammable. The U.S. Navy has done a lot of health and toxicity studies along the HFO solvents, and they've actually certified it to be used in breathable oxygen systems, such as the OBOGS system aboard an aircraft. So, such a fighter plane or any naval aircraft that's generating oxygen on board, you can clean out those systems with HFO solvents, and that's certified safe by the Navy. So we're comfortable very much that it's non-flammable and it's safe. So we've taken out all of the PFAS flame retardants in our CYBERSOLV 140X, and we'd like to introduce the new product CYBERSOLV 141K. All right, it's a simple update on the X. It's, like I said, it's free of PFASs. It replaces all of those with environments that the performance is as good or better than the previous generation. Because remember, we're keeping that same cleaning agent, the trans, but we're just replacing the flame retardants to make sure that the aerosol can is safe for use at your plant. So let's take a brief look at the physical properties, right? Top shelf, the health and safety, it's actually not going to change. On the left, you've got the new product, the 141K. On the right, you've got the previous generation product, the 141X. So harmful if swallowed, general idea is it's not good to swallow a solvent, so please don't do that. But health, fire, reactivity, you're looking at a 100, just like the previous solvents. Physical properties, it's actually got a slightly lower boiling point, which is advantageous because when you're reworking a PCB and you're using one of these little spray cans, you really want that solvent to evaporate fast off of the PCB so you're not leaving anything behind. So it'll evaporate a little bit quicker, leaving you with a clean, dry board, which is great. And the density is slightly less. But other than that, it stacks up pretty much the same as our previous generation solvent, which is great because very often we get pushed into something a little too early and the newer generation just doesn't work as well. That's not the case here. We've shown that the physical properties are similar and the performance is just as good. But just for good best practices, let's take a look at what could go wrong and what is the best thing to do when you're using these aerosol cans. So, the very first thing is if by chance you aren't using an aerosol can and you are using IPA, really leave that one for the barbecue, right? We really want you to use an engineered solvent in the aerosol can, whether it's ours or somebody else's. Obviously, we prefer ours over IPA for exactly what we talked about earlier, right? IPA is flammable. There's no flame retardants blended in to an IPA solution. So you've got a little piece of flammable solvent just sitting on top of your workstation if you're using IPA. That's really not a good idea. That's why we go through the effort of making these engineered solvents such as the 141K. The other thing is IPA is just not a good flux cleaner, right? We really designed this product to be a good flux cleaner to get rid of all of these residues on the boards. IPA just isn't. It's something that it's a commodity chemical that you can get off the shelf and it cleans as such. Secondly, technique matters. We'd love for chemistry to be selective and clean just the things that it wants, just in the places we want it to, but that's just not the case. If you've got a big complex circuit board like the ones on the left, the chemistry is going to flow everywhere. And on top of it flowing everywhere, if you've got dirty solvent flowing from a dirty part of the board to the clean part of the board, you're going to remove that dirty solvent and those contaminants elsewhere on the board. So a couple of tips for helping out with that. First, hold the assembly at an angle. Let it drain off in a direction away from other sensitive components where it has a clear path to get off the board. Clean the other areas as needed if they get contaminated. So if you know that you've got a particular area of the board that's in the center, angle it, see where that solvent path goes, and then flush it continuously with new solvent, just to make sure that you're not letting other solvent stay there. Use lint 3 wipes or precision cleaning swabs to contain the cleaning agent. You can create little dams on the board, and finish with either the same fresh cleaning solvent, IPA or DI rinse. The best one is the fresh cleaning agent. So you can have a can of the 141K to wash and a can of the 141K to rinse, just to make sure you're not leaving dirty solvent on the board. Also very important, you're only as clean as your tools. So make sure you're regularly cleaning your tools, that you don't have dirty tools going and scrubbing on a clean board, because they're just going to recontaminate or redeposit different soils on the board. And that's as simple as swabbing out fresh Q-tips or cleaning your brushes with solvent as you go. And finally, rinsing. Rinsing is really important because that's the last thing that's going to touch the board. All of these aerosol cleaners, whether it's ours or someone else's, are designed to evaporate off quickly. So as you can see in our little chart here, in step 1, you have flux residue around the solder joint. You clean that residue off of the solder joint, but if the solvent evaporates in place, you've just moved that residue to a different area of the board and left it there. So in order to prevent that from happening, make sure you rinse it. Get a clear path of flow from wherever you're cleaning to off of the board. And when you flush that out with clean solvent, you'll make sure you're not redepositing or leaving any of those flux residues just in a different place on the board. Choose the direction of your spray carefully, right? That is one of the biggest tips we can give, is try not to push it underneath a different component, such as a BGA, where you're never going to get those residues out, or at least it's going to be very hard in a hand process. Angle the board in the appropriate direction so that the residues go into open areas and off the board, and rinse it thoroughly. So those are the main things that we can tell you to help you have a successful rework process. I hope it helps, and we've got a few frequently asked questions on the topic that we'll go through as well. All right. So one of the biggest ones is, if you switch to the 141K, will the transportation regulations change? No. Even though we've got slightly different components in it, all the transportation regulations are the same between the previous generation product and the current product. How will the density difference affect the amount of solvent I receive? That's a really good one. Actually, it will have no effect in the aerosol cans, because those are volume. So you're going to get the same amount of volume with the new product as you will with the old product. However, if you buy the solvent in bulk and use your own Sure Shot or other pressurized sprayer, it's actually going to help you, because us and most other people sell these solvents by the pound. So a less dense product is actually going to contain more gallons in a 45-pound pail. So for example, on the previous product, I think we were about 4.2 gallons in a 45-pound pail of solvent. and now we're almost up to 4.5. You would get about a 15% increase in volume with the new product, which is great. Are there other trans blends that are sustainable? I'm sure there are. I'm not familiar with absolutely everybody's product, but one thing that I would encourage you guys to look out for is one of the things that we're seeing as 3M leaves the market is that other people are claiming to have drop-in replacements for their products, but all they're doing is replacing the 3M chemical with this same chemical manufactured outside of the US. So they're sourcing it from China or somewhere in Asia, and they're not actually removing the PFAS. They're just not buying that material from 3M. So please beware of that. Make sure that if you really want to have a PFAS-free product, that you trust the person you're buying from, and you're looking at that SDS to make sure that there's no PFAS in your product. So that's all we have for today. I'm going to turn it back over to William. Thank you all very much for attending.
Thanks, Jason. Thank you guys for watching this Tech to Tech session. If you'd like to discuss this topic further or have any questions not answered in the session, please contact your local KYZEN regional manager or send an email to tech@kyzen.com, and we will have someone follow up with you as soon as possible. And if you like this video, be sure to follow us on our social media platforms for more expert cleaning content.